So we said in the very first video about surface integrals that if you wanted to integrate over a vector field over a surface, here this would be the formula. You take your vector field f, you dot it with this cross product that we've been computing, partial derivative of r with respect to u cross partial derivative of r with respect to v, and then integrate over whatever bounds that u and v have over the surface. So in the light of what we talked about with flux and the normal vector, let's talk about this a little bit differently. So here's another way to think about this. This is f, this is notation they'll use, ds with a vector, because it's going to be f dotted with something. And remember when I said with the pillowcase that if you had some surface, if you're flowing perpendicular to the surface, that's the most efficient. If you're flowing some other way, like tangent to the surface, that you're not going through at all. There's no water flow, no heat flow, whatever you're calculating, no electric flow there. What should we dot f with? Well, we should dot f with the unit normal vector, basically vector n, or sometimes they'll say n hat, along the whole surface. And what is n? Well, remember we took these, we took that little parallelogram with RU and RV, and that gave us the tangent plane to the surface. So n should be perpendicular to both of those. So actually, this normal vector is going to be in exactly that direction, RU cross RV. And if we want to make it a unit normal vector, just so that the size of the normal vector doesn't affect us, we can divide by the magnitude of that cross product. But then ds, or I think sometimes I called it dA, that was actually replaced by, from before, this magnitude, and then du dv. So what ends up happening is that these magnitudes cancel out, and then you're left with, we're integrating over s still, f dot r sub u cross r sub v du dv. And that's exactly the formula that we talked about. We didn't give a lot of justification for this before, but in the light of the normal vector, maybe this makes a little bit more sense.